What is going on, YouTube? Welcome back to another video, and in today's video I'm going to tell you guys about salamanders that jump from the tallest trees in the world. These are actually skydiving salamanders that live in the redwoods out in California, and I learned about this and I thought it was super cool, so we're going to go ahead and cover the article and explain how exactly to do that. Before we do that though, guys, please remember to hit that like, comment, subscribe, as well as turn on that notification bell. Follow me on all my social medias, and let's get into the article. Like I always say, guys, I don't own the rights to these articles. I just use them to push along information. This particular article is coming from universityofcalifornia.edu. Please go over there and show them some love. Skydiving salamanders in the world's tallest trees. Salamanders that live their entire lives in the crowns of the world's tallest trees. California's coastal redwoods have evolved a behavior well adapted to the dangers of falling from high places. The ability to parachute, glide, and maneuver in midair. Flying squirrels, not to mention numerous species of gliding frogs, geckos, and ants, and other insects are known to use similar aerial maneuvers when jumping from tree to tree or when falling, so as to remain in the trees and avoid landing. Similarly, these researchers suspect that this salamander's skydiving skills are a way to steer back to a tree if it's fallen or jumped from. The better to avoid terrestrial predators. So I think it's missed it. These are actually wandering salamanders, is their name. While they're parachuting, they have an exquisite amount of maneuverable control, said Chris Brown, a doctoral candidate at the University of Florida in Tampa and first author of a paper about these behaviors. They're able to turn, they're able to flip themselves over if they go upside down, they're able to maintain that skydiving posture and kind of pump their tail up and down to make horizontal maneuvers. The level of control is just impressive. The aerial dexterity of the so-called wandering salamander was revealed by high-speed video footage taken in a wind tunnel at the University of California, Berkeley, where the salamanders were nudged off a perch into an upward moving column of air, stimulating freefall. What struck me when I first saw the video is that the salamanders, are so smooth. There's no discontinuity or noise in their motions. They're just totally surfing in the air. That to me implies that this behavior is something deeply embedded in their motor responses, that falling must happen at a reasonably high frequency so as to affect selection on this behavior. And it's not just passive parachuting either. They're not just skydiving downwards. They're also clearly doing the lateral motion as well, which is what we would call gliding. The behavior is all the more surprising because the salamanders, aside from having slightly larger foot pads, look no different from other salamanders that aren't aerially maneuverable. They have no skin flaps, for example, that would tip you off to their parachuting ability. Wandering salamanders have big feet. They have long legs. They have active tails. All of these things lend themselves to aerial behaviors, but everybody just assumed that was for climbing because that's what they use these features for when we're looking at them. So it's not really a dedicated aerodynamic control surface, but it's functional as both. It helps them climb and it helps them parachute and glide as well. Among the questions the researchers hope to answer in future research are how salamanders manage to parachute and maneuver without obvious anatomical adaptations to gliding, and whether many other animals with similar aerial skills have never been noticed before. Salamanders are sluggish. You don't think of them as having particularly fast reflexes. It's life in the slow lane, and flight control is all about rapid response to dynamic visual cues, and being able to target and orient and change your body position. So they said. So it's kind of odd, how often can this be happening anyway, and how would we know? A paper describing the behavior was published today, May 23rd, in the journal Current Biology. Using the wind tunnel, Brown and UC Berkeley graduate student Eric Staith compared the gliding and parachuting behavior of A. varginus, adults are about 4 inches from the snout to tip of the tail, with the ability of 3 other salamander species native to Northern California, each with varying degrees of arboreality, that is, the propensity to climb or live in trees. The wandering salamander, which probably spends its entire life in a single tree, moving up and down but never touching the ground, was the most proficient skydiver. A related species, the so-called arboreal salamander, A. lugubrious. Why do they gotta make scientific names so hard? Which lives in shorter trees such as oaks, was nearly as effective at parachuting and gliding. 2 of the least arboreal salamanders, I'm just not gonna try anymore. The speckled black salamander, which occasionally climbs trees, essentially flailed indefectively before the few seconds they were airborne in the wind tunnel. All 4 species are plethodontid or lungless salamanders, the largest family of salamanders and mostly found in Western Hemisphere. The two least arboreal species flailed around a lot. We call it ineffective undulation motion because they don't glide. They don't move horizontally, they just kind of hover in the air. They just kind of hover in the wind tunnel, freaking out, Brown said. The two most arboreal species never actually flailed. Brown encountered these salamanders while working in California's Humboldt and Del Norte counties with nonprofit and university conservation groups that mark and track the animals that live in the redwood canopy, primarily in old-growth forests some 150 feet off the ground. Using ropes and ascenders, the biologists regularly climb the redwoods, the tallest of which rise to a height of 380 feet, to capture and mark wandering salamanders. Over the past 20 years, as part of a project led by James Campbell Stickler, now director of the Sequoia Park Zoo in Eureka, the researchers discovered that most of their marked salamanders could be found in the same tree year after year, although at different heights. They live primarily in fern mats growing in the duff, the decaying vegetable matter that collects in the junctions of large branches. Brown said that a few marked wandering salamanders from the redwood canopy have been found on the ground, and most of those were found dead. Brown noticed when picking them up to mark them that the salamanders were quick to leap out of his hands. Even a light tap on a branch or a shadow passing nearby were enough to get them to jump from the redwood canopy. Given their location high above the forest floor, their nonchalant leaps into the air were surprising. They jump, and before they've even finished towing off, they've got their forelimbs splayed out and they're ready to go, he said. So the jump and parachute are very closely tied together. They assume position immediately. When he approached Dudley, who was studying such behavior in other animals, he invited Brown to bring some of the salamanders into his wind tunnel to record their behaviors. Using a high-speed video camera shooting at 400 frames per second, Brown and Saith filmed the salamanders for as long as they floated in the column of air, sometimes up to 10 seconds. They then analyzed the frames to determine the animal's mid-air posture and to deduce how they used their legs, bodies, and tails to maneuver. They typically fell at a steep angle, only 5 degrees from vertical, but based on the distance between branches in the crowns of redwoods, this would usually be sufficient for them to reach a branch or trunk before they hit the ground. Parachuting reduced their free fall speed by about 10%. Brown suspects that their aerial skills evolved to deal with falls, but have become part of their behavioral repertoire and perhaps their default method of descent. He and USF undergraduate Jesselina Ortiz found, for example, that walking downward was much harder for the salamanders than walking on a horizontal branch or up a trunk. That suggests that when they're wandering, they're likely walking on flat surfaces or they're walking upward, and when they run out of habitat as the upper canopy becomes drier and drier and there's nothing else for them up there, they could just drop back down to those better habitats. He said, "Why walk back down? You're already probably exhausted. You've burned all of your energy. You're a little 5-gram salamander and you've just climbed the tallest tree on earth. You're not going to turn around and walk down. You're going to take the gravity elevator." Brown sees Avergarnus as another poster child for old-growth forest that is akin to the spotted owl because of its found primarily in the crowns of the tallest and oldest redwoods, although also in Douglas firs and Sitka spruce. This salamander is a poster child for the part of the redwoods that was almost completely lost to logging. The canopy world, it is not there in these new growth forests created by logging companies, he said. Perhaps it would help not just efforts in conserving redwoods, but restoring redwoods so that we could actually get a canopy ecosystem. Restoring redwoods to the point of fern mats, to the point of salamanders in the canopy, that would be a new bar for conservation. In the meantime, these denizens of old-growth forest has a lot to tell us about evolution and perhaps the origin of flight, said Dudley. It's gliding. It's a novelty, something unexpected in an otherwise well-studied group of animals, but it illustrates the urgency with which animals that are living in trees must evolve aerial capacity, even if they don't have wings, Dudley said. Flight in the sense of controlled aerial behavior is very common. They're controlling their body posture and they're moving laterally. This predisposes many things that are living in trees to ultimately evolve. Flapping flight, which is probably hard to evolve, and why it has only turned up 3 times on the planet today. Yeah, guys, there's a lot of information about skydiving salamanders, or the wandering salamander, if you guys want to get technical. So I'm gonna go ahead and show you guys the video. It's on YouTube. It says Skydiving Salamanders, so it's also in this article, so I guess we can check that out. So yeah, let's just go on over and do that. said, please remember, like, comment, subscribe. Let me know what you guys thought. Follow me on my social medias, and I'll see you guys in the next video.